Hey, all you Gretas and Chatezcats out there. Welcome to Unit 8, Sections 12 and 13. We're going to look at hazards and risks. So we got a lot in this section. There are 5 types of hazards. Once again, pretty much anything Homer Simpson does. First one is biological hazards. We have over 1,400 pathogens out there. Your chemical hazards, most of the stuff you can find under your sink, in the bathroom, or in your garage. Natural hazards, fire, earthquake, floods, storms, volcanoes. Cultural hazards, which can be fixed, in theory. Things like unsafe highways, poverty, unsafe working conditions, assault. And then your lifestyle choices, which is definitely within your control. Things like smoking, alcohol, drugs, unsafe sex, driving fast, eating poorly. We have 2 kinds of hazards. We can have non-transmissible hazards caused by a non-living factor, does not spread. And then you have your infectious disease. So these would be most of your biological hazards. They can be transmissible, contagious, communicable. Any of those words could work instead of infectious, and these are caused by various pathogens. So you can have your viruses are really, really small, and then you've got your prokaryotes, which are your bacteria, and then your eukaryotes, which are your parasites, your fungi, and your larger things. So just to give you an idea of how small these things are in your body. So modes of infectious disease transmission, and after this year, this should look very familiar to you. So for your abiotic environmental factors, you can have things like wind and water cause inhalation of spores or even entry into skin. So I remember I was outside once and the wind kicked up and all of a sudden I was coughing and hacking. So some pollen that was in the air just got blown into my lungs. Water, entry into skin. This is why you don't go into the ocean for a month after you get a tattoo, because that's a big old open wound that you are exposing to the ocean. People have gotten some really gross infections when they go into the water after getting a new tattoo. Don't do that. You can also have animal vectors. So things like mosquitoes or fleas are your most common ones, bringing you fun and exciting diseases like malaria or bubonic plague. And then we have our human-to-human transmission. So these are your direct contact. So first we have direct contact. So this is the pathogen survives best inside the body. So a lot of things, your STDs are going to be in this category because you need to touch the other person to be sexually transmitted. Ebola is also on that list. Indirect contact. So maybe somebody touches a doorknob after coughing on their hand, and then you touch the doorknob after the fact. Pathogens can survive into a fairly harsh environment. You can pick it up from the surface or the air, things like the flu or norovirus. Then we have droplets. Droplets are in the air. Pathogens are found in those droplets, but they don't survive long. So if someone sneezes on you or coughs on you, then you can be exposed to those. Airborne pathogens are aerosolized, I almost got that out, and they stay infective. They can infect you for a while. So that just it hangs out in the air, and then you can breathe it in later. And then you can have the fecal-oral route, yum, through contaminated food or water. So a lot of your food poisoning is this way. E. coli, if you've ever had E. coli, there was poop in your food. Things like cholera is poop in the water, norovirus, Shigella, lots of fun things, usually causes a lot of diarrhea. Yay. So this is fun. Let's see if it'll load.
Grammarly
oh my gosh.
does more than catch errors. With Grammarly,
sorry guys. Okay, we won't watch all of this, but I want you guys to just see when somebody sneezes. This is why we wear masks. Oh, let's get to the fun part. Can you imagine volunteering for this video? All right, so here comes the sneeze. All that's coming out of you. So that's coming out when you sneeze. It's just going too fast for people to see. This is why we wear masks. I don't think I'd even want to be the camera person recording this. So next time somebody sneezes next to you, this is what I want you to picture. That was fantastic. All right, back to notes. All right, so epidemic is a regional large-scale outbreak. A pandemic is a worldwide outbreak. All of you should know that really, really well. So we have our various outbreaks that have happened in history. Smallpox knocked out over 300 million people. Its transmission is droplets. Its pathogen is a virus, and there is a vaccine for smallpox. We don't even get that vaccine anymore because it worked so well. That is why. Because some people are like, why don't we don't even need that vaccine? Because it worked. We got rid of it, guys. Next round is measles. Has killed over 200 million people. This is airborne. It is a virus, and we do have a vaccine for it. Hopefully all of you have had your vaccine for measles. Next round is Spanish flu. This is droplets again, and this is once again a virus, and we do have a vaccine for this one now. So this was only 2 years, more or less, and we wiped out 50 to 100 million people. So that's pretty powerful. There we go. Black Death is our next one. Lasted a little bit longer, took out 75 million people. Came from flea bites, which were off of the rats. This is a bacterium, which means we do have an antibiotic for this. I would say in the United States, maybe 1 or 2 people get this a year. They take their antibiotics and they're fine. And then HIV/AIDS, since the 80s till now, has killed over 25 million people. This is through sexual contact and or needle sharing. This is a virus, and we do not have a vaccine for this. This is an RNA-based virus. This is a retrovirus, so it mutates so fast that we can't come up with a vaccine, at least with current technology. So one of you guys get on that for the future. Looking at flus, please get your flu shot every year. That would be really good. Antibiotic resistance is going up as people are exposed to more antibiotics when they don't need to. We also have a lot of antibiotics in our crops and our food. So antibiotics are given to both food-producing animals and crops to keep infections down. So instead of waiting for an animal to get sick and then treat it, they just treat them proactively with antibiotics, but then it gets into the food and it gets into us. So animals are going to develop those gut-resistant bacteria in their guts. It's going to reach us through the food, the environment, or direct human-animal contact. We now have this drug-resistant bacteria, which is going to spread to other people, and then you can get your antibiotic resistance. So issues that you can do, overprescribing of antibiotics. If you don't have a bacterial infection, you do not need antibiotics. So feel free to say, no, stupid doctor, I don't need these. If you are prescribed antibiotics, make sure you finish the treatment. Even though you start feeling better, you still have bacteria in you. Kill all of them by taking all of the pills as prescribed. Overuse of antibiotics in livestock and fish farming. Buying more organic and locally grown stuff from the smaller farmers will reduce that. The CAFOs is where this is the biggest issue. Poor infection control in hospitals and clinics. I've read that more people get sick inside a hospital than out. I don't know if that was pre-COVID. But just be aware when you're in a hospital. Sometimes they're not the best at keeping things clean. Make sure you are keeping yourself hygienic and clean. And then if we're not developing new antibiotics, those are also issues. So solutions to infectious disease. And I think this is kind of where we left off yesterday. So we can research our vaccines, which we've seen over the last year. We can reduce poverty and malnutrition. We can improve drinking water quality. We can reduce unnecessary antibiotic use. We can reduce use of antibiotics on livestock. We can get immunizations. If you qualify for something, please get it. Flu shots every year. And then awareness campaigns. So STD, this is how they're passed. Sometimes people don't know. Mosquito nets and whatnot. So top 5 substances, toxic substances, and what they are. So arsenic, lead, mercury, PVC plastics, vinyl chloride, and then your PCBs, your polychlorinated biphenyls. These are found everywhere, and they are fat soluble, which means they go through that whole fun biomagnification process. So all of these Chlorpyrifos is a bug killer. These are all neurotoxins in certain amounts. The fluoride in your toothpaste is fine, but if you overdose on fluoride, you can have neural issues. So the easiest ones to remember are your lead and your mercury, because those are the ones that probably you're going to be more likely to be affected by, or the easiest examples. But all of these are neurotoxins, so you have to be aware of your consumption levels. So 3 types of toxic agents and what they do. We have our carcinogens, which cause cancer. Nice and easy to remember. Mutagens will cause mutations in your DNA, and then your teratogens cause birth defects. So none of these are fun, but different kinds of toxins do different things. So a carcinogen examples are things like tobacco, UV rays, asbestos, radon, acrylamide, which is found in a lot of fried foods. Processed meat has actually been declared a carcinogen because of the chemicals in it. Ugh, so gross. Alcohol is a carcinogen, as well as car exhaust or any other kind of exhaust. Mutagens, ethidium bromide, UV rays, and X-rays. So just be aware of how much time you're spending in the sun, or use that fun stuff called sunscreen. And usually your guys aren't exposed to too many X-rays, but that's why they have you wear those lead aprons, or they cover you with the apron before you get your X-rays. Teratogens, alcohol, cocaine, mercury, and lithium. So let's just go ahead and limit your exposure to all of those. Especially ladies, when you're pregnant, stay away from alcohol, cocaine, mercury, and lithium. That would be one heck of a pregnancy party. Just stay away from them. Do that. So the things that affect the immune system: arsenic, methylmercury, and dioxins. These are a lot of your stuff that we've talked about is going to kind of repeat on other sides of things. Your nervous system, we have neurotoxins. So methylmercury is a big one, PCBs, arsenic, lead, and other pesticides. Endocrine disruptors, which mess up your hormones. BPA, which is found in your disposable water bottles. It's also found in those heat-sensitive receipts, which is like every receipt out there. If you notice, some places people will have gloves on, so they're not touching the receipts. Aluminum, phthalates, and DDT are all endocrine disruptors. So an immune system, this is going to weaken the immune system, making it more vulnerable to infection, so more likely to get sick. Your neurotoxins can result in things like mercury poisoning. These things can actually cause ADD. So if a woman is exposed to some of these things when they're pregnant, maybe then the child ends up with ADD. Can result in paralysis and or learning disabilities. So stay away from these things. And then for endocrine, they prevent the hormones from working properly. They can result in birth defects or developmental delays and disabilities. Moving on to toxicity. This is a measure of the harmfulness of a substance, the ability to cause illness, injury, or death to a living organism. How toxic is something? So a dose is the amount of a chemical that a person has ingested, inhaled, or absorbed at one time. Weird overdoses we're going to skip. Think of factors that affect toxicity. The first one is age. So depending on what you are taking and how old you are, the dosage is going to be different. Genetic makeup, and there's multiple chemical sensitivities to that, but your genes can determine how easily you can take a certain pill or toxin. What is multiple chemical sensitivity? So this is a chronic condition where the patient experiences an inflammatory reaction to various chemicals. Sometimes a fragrance, VOCs, foods, and common household products. They typically will become more sensitive over time. So this is like really not fun. You can have a lot of different things that you are sensitive to. So not something fun to have. Performance of detox systems. So your liver, your lungs, and your kidney, you want these things as happy as possible. All of those detox products out there don't work. These 3 things detox. So you have your liver, you have your lungs, and you have your kidney. This is your detox system. So as long as these things are healthy, you are properly detoxing. We also have solubility and persistence. How much or how soluble is it? So how easy is it to get to you? And then how long does it stay in an area will also affect things. And then you also have to look at, does it go through biomagnification and bioaccumulation? Because that would then be a larger issue for those of us at the top of the food chain. All right, so types of response. You can have what is called an acute response, which is an immediate, rapid, possibly temporary. So for example, an asthma attack or even getting the flu. You are exposed, you have a response, you're going to get over it. Chronic is more permanent or long lasting. So maybe being diagnosed with, say, cystic fibrosis would be a chronic issue. Not to say acute can't be very serious, but it usually comes on very quickly and possibly can be temporary. So toxicity, according to the EPA, you don't need to know these. This is just interesting. Lead contamination in water cannot exceed 15 parts per billion. Mercury cannot exceed 2 parts per billion, and chromium cannot exceed 100 parts per billion. So we don't have to discuss this because you don't have neighbors. But think about, why is the level of contamination set by the EPA different from pollutant to pollutant? Things are going to be different. The toxicity of things is going to be different depending on what it is. So different amounts of a chemical are going to be more or less toxic. And so how do they come up with these things? They figure out the LD50. This is called LD50 or lethal dose 50. This is the amount of a substance required to kill 50% of the test population. So lethal concentration 50 is the amount required to kill. But we mainly focus on LD50 is the main thing to focus on there. So rules of thumbs about LD50 is it's applicable technically only to the test population. We're never going to test these things on humans. And the lower the dose, the more lethal the substance. So here are examples. So which are the most and least toxic substances? This is a teeny tiny little number. So the pufferfish poison, the texadotoxin, is really, really, really lethal. Versus a moisturizer, you'd have to take a whole lot of it in order to kill yourself on some lotion. Technically possible, but really hard. So is LD50 directly or inversely proportional? So the higher the number, the less toxic it is. So they are inversely proportional to each other. And then there are 60 milligrams of phosphoric acid in a Coke. Here's your phosphoric acid somewhere on this list. How many Cokes would you have to drink to die of phosphoric acid poisoning? Here we go, in your sodas. So it would take this many grams, which is in that many Cokes, 1,733. So if you could put away 1,733 Cokes in one sitting, you could kill yourself on phosphoric acid. Please don't do that. So once again, the LD50 of a substance indicates the dosage that kills 50% of the test population. The higher the LD50, the less toxic the substance is. And then to figure out the LD50, you graph your data if you are given data, and you connect the dots. You do not do a best fit line, you connect the dots, because then what you're going to do is go over to the 50%, go over to wherever it connects to the line, and then go down, and whatever that number is there, that is the LD50. Examples of toxicity. Kids put everything in their mouth, including batteries, because they don't know any better. And so they've actually reduced the amount of cobalt in the batteries to help reduce the poisoning of children, which is kind of nifty. More examples. Animals can have vitamin D, good for you. Too much vitamin D, bad for you. Flint is an example of the toxins in the water. So we have what is called a precautionary principle. So this is when there is substantial preliminary evidence that an activity, technology, chemical substance can harm humans or the environment, that we should take precautionary measures to prevent/reduce harm rather than wait for more conclusive evidence. So these were the people who were like, hey guys, until we know what's going on, let's go ahead and wear masks and social distance as soon as possible instead of waiting. And this way we can maybe reduce the issue, reduce the amount of COVID. So the people who were all about it before it was officially mandated, they were using the precautionary principle. As long as you have substantial evidence, yeah, let's go ahead and try it. So some people, like this frog in boiling water, say we will get out when you prove we will be boiled alive. They need that proof, and you know these people, as opposed to we should get out until you can prove we won't be boiled alive, because maybe sitting in a pot of water on a stove is not the best idea. So there's definitely evidence this isn't a good call. Using the precautionary principle, let's just use those precautions until we know more. So more definitions for you guys. Risk is the probability of suffering harm. And so we did that risk analysis earlier, this unit. It's usually a percentage or a fraction. Risk assessment, and there are people out there who do this, use statistical methods to estimate the risk of an activity. And then risk management is whether and how to reduce the risk and at what cost. So a lot of times after someone has a stroke or a heart attack, they kind of do a risk management of their life. Hey, am I working out enough? What's my diet like? Am I getting too much salt? Am I getting not enough nutrients? So they do a risk management and then often change how they're doing stuff. So the last little thing is talking about which one of these things do people consider to be riskier, and then what are the reasons behind these? So your first example on your packet is being pushed out of an airplane with a parachute or skydiving. Most people don't want to be forced to jump off of anything, but others pay. I have gone skydiving and it was super fun. So if it's involuntary, people perceive it as having a higher risk, but if you have a choice, even if it is a risky activity, people will perceive that action as having less risk. Your second option is the government chlorination of drinking water versus a chemical water softener in your home. So this is what you can control versus what you can't control. So if you're not in control of an action, like putting chlorine in your drinking water, they tend to think that carries a greater risk, even if it doesn't. But this is how people think because we are human. But when they're in control of an action, using a chemical water softening system in their home, which is, once again, chemicals, they tend to think the action carries less risk because they're in charge of that. The next one talks about hiking on an open cliffside trail or living next to an oil refinery. Well, that cliffside trail is very natural versus the industrial nature of an oil refinery. So we tend to associate the more industrial, the more risky it is. But you could fall off a mountain. The next one talks about driving in a car, which you've all done, versus living near a nuclear reactor, which none of you probably have done. So that looks at the unfamiliar versus familiar. You drive cars every day. You see people driving cars every day. Most of them turn out 100% fine. But people tend to be very fearful of living anywhere near a nuclear reactor, even though car accidents kill thousands of people annually, while nuclear reactor accidents have resulted in 3 deaths in North America. So a car is way more dangerous than living next to a nuclear reactor. And there's actually more radiation living next to a coal power plant than a nuclear reactor. The next one talks about using tobacco versus using a product containing dioxin. This is not on yours. Oh, catastrophic versus ordinary. So, sorry, I lied. Driving in a car, again, versus flying in a jet airplane. So the ordinary thing is flying or driving in a car. A jet airplane, they might make the news, and a whole bunch of people die at once. But once again, driving the cars are more dangerous. Car crashes rarely make the news. Jet crashes always make the news. All right, now, tobacco versus dioxin. Everybody knows tobacco is bad for you. Even smokers will tell you they know it's bad for you. Versus something like dioxin, we don't know what that is. Many people don't know what dioxin is, and so they're much more uncertain about that. The next one talks about drinking tap water in your house in apparently Cupertino versus drinking tap water from a well in Senegal. So drinking water from the tap in a developed nation, no big deal. But if you're drinking a cup of water from a well in a third world country, or sorry, a developing country, they may think twice about that. Can they trust it? Fair versus unfair, this last one. Living in near a factory that exports goods, so a factory that makes stuff that you don't use, versus living in a factory that sells goods that you do use. So this is fair versus unfair. People in lower socioeconomic communities who face health risks more than those in more affluent neighborhoods often feel a sense of outrage because not only are they being exposed to stuff because of this industry, they're not even getting to use the stuff. So risk without a benefit is seen as definitely unfair. And then here is just some really fun ways that people died in 1632. So some of them, I don't even know what some of these mean. So aborted and stillborn, there were 445 babies. Someone was affrighted. They were scared to death. 628 died of old age, bit with a mad dog, bruising, burnt and scalded, cancer and wolf. So not just one, cancer and wolf. Lots of coughs and colds, consumption, so maybe like obesity, cut of the stone. Somebody hit him with a stone. I don't know. Dead in the street and starved. 6 people. 6 people. Executed and pressed to death. That was a bad way to go for 18 people. Fever, fistulas, smallpox, Frenchpox, gangrene, gout, grief. 11 people were so sad they died. I don't know what that word even is. Killed by several accidents. 46 people had a very unfortunate day. King's evil. I don't know what that is, but that is phenomenal. Lethargy. Some of you can be lethargic, so get up and do something. It could kill you. Made away themselves. I'm assuming that's suicide. Measles. Plague. Planet. Earth got him. I don't know. Rising of the lights. I don't know what that means, but that sounds exciting. Suddenly, 62 people just died. Teeth. Bit to death. Maybe a tooth infection. I need more information. 1 person died from vomiting and 27 people died from worms. So super fun time. I just thought this was really interesting to see different ways that people died back in 1632. So that is it. And before we go, I would like to say you are good enough, you are smart enough, and people do like you. And in case I don't see you, good afternoon, good evening, and good God, do your homework.